Alright, so welcome to this real-time LabView tutorial. This is actually part 4 where we actually get into how to set up things with LabView and the NI stuff. Alright, so we're gonna kick off really quick here. This is a VI, and this VI is used to set up the deployment from the host to the target. We're gonna specify which hardware we're using, and we're also gonna use it for monitoring our variables. Those are the main three functions of this VI we see here. So really quick, you can see here some knobs and some waveform charts. These are all mapped to our Simulink model. Remember, we created a DLL file. This is where we can actually start monitoring and or controlling changing variables from LabView. So these are the things we're gonna map. So we're gonna go to Tools, SIT Connection Manager, and we're gonna get the connection manager. It might take a while to come up. I'm just fast forwarding here, so you're gonna see it load in its entirety. But so you get a window like this, and again I'm going really fast. You can see here this menu. This menu is really important. We'll go through it, the different parts of it. There's three main parts, setting the model, the mappings, the data logging, and the hardware I/O. So that's four main parts I should have said. So quickly going to the first one, we go here to this model and host, and we can see here it asks us to identify the target. So if we were to change it, here I have already set up for that NI desktop that I'm using. You have to specify that it's a real-time target and the port, which you get from that message I showed you, which you look at in Simulink, in MATLAB, sorry. So you select the model DLL. You have to go to that folder where your model is saved. Remember, in part 3 we went there and we actually located that DLL file. You can see here it has the name of the model, so we go there and we select this DLL file. And it automatically will select also the project directory, which is this thing below, the setting below. It'll automatically select it based on the DLL that you selected. So the mappings. Moving on to the mappings here. Here's the part where we map these knobs and waveform charts to what we have in our Simulink model. Here's where we can start monitoring variables and also control them. We can monitor them using these waveform charts, or we can just change variables using these knobs here. We'll map them. So the way you do it is you create this VI and you actually put the controllers in there. So you put the VI and the waveform charts, which is not difficult. Just right click and look at the menu, and then in this menu, when you're here, you're gonna right click on that indicator and it'll bring this window up, which contains all of the outputs from the Simulink model. In this case, if you're looking at an output, so you can see here it says spacevec generation code, an alpha and beta. I just mapped that to this waveform chart in here, whereas here this other waveform chart I've actually mapped it. If you can see here, it shows up all the embedded MATLAB functions that I had on my Simulink code. You can refer to the other parts of the videos to look at this, but here, it'll show me all the embedded MATLAB functions and their output ports. So then I can map all the 3 duty cycles that were my output from the Simulink model to this waveform chart here, and you can see the names there, the embedded MATLAB functions and the corresponding ports. Now here is the frequency. This is what I actually changed. I put this knob and I can actually map. Here I can map the frequency of the sinusoidal references that I had in my model, and then that's what I changed to see that frequency scaling thing I mentioned in the previous video. And then we have VDC and VDC scalar. These are just things in the model that we can go ahead and change. So the data logging, you might want to be able to log some data. So what we're going to do is you hit that plus sign to create a new configuration. So you real quick, I'm going real quick on this. So space vector test for video. Okay, so yeah, just name it whatever name you want, and you set the name of the data log file name. So the file name will appear under that name with the extension that you selected. In this case, we're going to select txt, or you can actually do a TMS file. This is pretty convenient. You can actually select to log all the samples or just n samples. And then this here will be the timestamp. That means that you can select how much information do you want in your file name. You know, you can have a file name that says SV test, like I have here in the data log file name, and then and right next to it it'll show like the day of the day, the month, the year, the hours, minutes and seconds, and so on. So here's the window where you can actually select which ones you want or you don't want. I usually take out, you know, like the year, because I know what year I'm working on. I usually leave the essentials, like the month and the day and the hour and the minute. That's usually what I do. So the next thing is you go to configuration mappings, and here you can see what's on the right, which is model signals. So this corresponds to Simulink. This is the part that corresponds to Simulink. I'm gonna fetch it real quick here. This is MATLAB. So yeah, see here the embedded MATLAB functions, whatever name, however you name them here, they'll show up on this LabView thing. So you can see here embedded MATLAB function 3, 4, 5, and those are the ones that contain the duty cycle. So let's say I would just want to log the duty cycle, so I'll just pick these 3 outputs from the 3 embedded MATLAB functions, and I'll just add those to my data logging file. So that means I'll log these 3 signals when I run the system. Alright, so the last part is actually mapping the hardware I/O, and this is a very important part. So you click and configure hardware I/O, and it'll give you the IP of the computer you're working on. So you're gonna go ahead and hit add device and IFPGA, and here's where you actually select the hardware you're working with. In this case, I have already set it up in here, so it won't show up. But yeah, but you know, you select it, and then you should see a window like this, where you can see, you know, this is what'll show up. It should show up that you have an RIO0 device, PCIe 7852R device, and that's your FPGA target. So you're gonna go ahead and select that. Like I said, in this case, I already have it there. So rather than add a new device, I'm just editing the properties of it. So here's the FPGA bit file, and this is that file we created when we compiled our VI that contains the information on the hardware. So yeah, we go ahead and select that LV bit file that we created, if you recall from the past videos, and then it gives us this tree here, and this is what we obtained, you know, when we compiled. So you remember we selected 4 analog inputs, and you know, whatever the duty cycles were, and then this part here will give us the model outputs. This is again the Simulink outputs that can be mapped to these parts right here. So for example, I can just, here I have, for example, I already have mapped my 2 analog outputs. So I have these signals here from these 2 blocks, V alpha and V beta. I have them mapped to analog outputs 0 and 1. If you recall, we just selected 2 analog outputs when we were setting up everything and we were compiling. So yeah, again, this is, you know, this is all the connectors we have available, and then these are the variables from the model on the right, and then we can map these. For example, here I'm mapping the 3 duty cycles to 3 variables that I have generated in my LV bit code. Alright, so yeah, so you know, I take the variables from here and I map them to the model, to these over here, which correspond to the model. So this is mapping hardware versus model, whereas in the other mapping it was software, that is this VI that we have in the background, with the model. So we're pretty much done with that, and we're gonna go ahead. Okay, it may take a while for it to, you know, while it finishes everything, and once it finishes, then you're pretty much good to go. So you can go ahead and click on this white arrow over here, and it should deploy. So you can see here's a window that says progress. So it says preparing for deployment. So this might take a while, and then this will be the part where it deploys the whole thing to the target. Now that you have configured it, it'll deploy it to your target computer, and then you should be able to run it. So after that, you'll hit that green arrow you can see there under model controls. Just click on that and you should be good to go. Then the program will start running on the target and you should be able to monitor whichever variables you want. And thanks for watching this video, and good luck. Again, if you have any questions, you can always refer to the NI documents or just contact NI. They'll have plenty more information than what I have. Alright, thanks a lot and see you.